It is now over 2 years since Rosetta made its rendezvous with comet 67P Churyumov-Gerasimenko. Back then it was 100 kilometres away, but after some complex operational manoeuvres it began a series of flybys and orbits at increasingly shorter distances. The comet, alongside the spacecraft, is now heading towards Jupiter, and Rosetta is nearing the end of its mission. But recently the orbiter got spectacularly close to the surface, up to an amazing 3 kilometres, allowing detailed views of the comet's cliffs, boulders and plains. A year ago this would have been impossible. The comet was at perihelion, its closest distance to the Sun, and also at its most active, spewing out dust, gas and plasma. This meant Rosetta had to remain at a safe distance of up to 300 kilometres. But these newer, closer passes mean that scientists can observe changes in the comet over time using onboard cameras such as a Ceres.
The most prominent, the most exciting changes on the surface, I believe it is still the big drop in the Imhotep plateau, which was 3 meters and 100 meters in height and hundreds of meters in radius. But we have seen smaller scale features like a boulder, which was at least 50 meters big, it was 10 tons heavy, which, well, on the comet is just a chocolate bar of 100 grams or so, but still it's a massive thing, which has moved by 140 meters. Likely due to activity, but we don't know the real reason.
Even as the mission is coming to a close, Rosetta remains busy. In June, it completed a 2-week remapping campaign of the comet's northern hemisphere to produce a new, higher resolution 3D model that can be used to see large-scale changes of the comet and also where it has lost mass. Mission scientists from the 21 instruments on board Rosetta and its Philae lander, which was finally switched off in July, have also combined findings to gain a more complete picture of the comet.
In particular, what we have observed is that the nucleus is composed of a mixture of materials like minerals, like silicates and sulfides, which have been formed in the inner part of the solar system, close to the Sun, at temperature relatively high.
It has been an audacious mission, gaining knowledge about the comet's surface, coma, tails and interior. But the final month still offers further scientific opportunities.
So at the moment, as it's really getting to an end, we will be able to get very close to the nucleus and make measurements that were not possible before. So that's the very exciting part of the end of mission scenario.
The end will be September the 30th, but it won't be the end of the mission science. When Rosetta spirals down to the comet's surface for a controlled descent, it will take images and perform measurements until impact. Excitingly, the landing site on the head of the duck-shaped comet is in a region with active pits. Data collected from Comet 67P will keep scientists busy for decades to provide our most complete understanding of a comet yet, and making history as the first ever mission to orbit and land on a comet.